Hey everybody, welcome back. We're continuing chapter 3 on vectors, and in the last segment we had just gotten done talking about just the definitions of vectors, how vectors have a given magnitude and they also have a certain direction as well. Now we're going to be looking at some of the properties of vectors and how they can be added or subtracted, various different math operations that can be done to them. So we can add vectors. So let's just say we have two vectors right here, vector A and vector B, and they're both what we would call maybe a displacement vector. All right, so vector A is going to be right here, and that might be, I don't know, 4 meters. Okay, I'm not going to write it right there, but I'll say it's 4 meters. We'll say we've got vector B, which is 2 meters. So that's vector B right there. So there's B, and A is going to be in red. And so adding them together, you can see that what we do to them is we put them, what we say is tip to tail. Tip to tail is kind of the naming convention, where the tip of the one vector goes onto the tail of the other one. And so we're essentially adding them together. We're adding them together to create kind of a third vector that we'll call vector C, and that'll be purple right here. And that'll be the sum of those two vectors. All right, we can add them together. And so vector C would be of magnitude of, what is it, 6, right? 4 plus 2 would be 6. We could also subtract them as well. Now subtracting is a little bit different. It's obviously different, but we don't just subtract a value, but what we really wind up doing is, say here we have vector A minus vector B. It's kind of like adding the negative of that vector. Remember, vectors are made up of magnitudes and the directions. You really can't have a negative magnitude. You can't go out and run negative 5 miles. What you can do is you can run 5 miles in the negative direction. So that's what we're going to do with vectors when we subtract them. So it's like doing this. It's like saying, okay, we got vector A right here. I'll try to make it the same one. All right, so that's vector A, and we're going to put the tail of B on the tip of A. But remember, B is going to be in the negative direction, so it's going to be opposite in this manner. It's going to be going back like that. It's a little bit longer than the original one, but that's okay. All right, so what that does is that creates, if you account for the original starting point, we're going to call this the original starting point here and here, original starting point, and that creates a resultant vector that's different from any of the previous ones. I'll make it green. All right, so vector, by the way, sorry if my microphone is scratching against my sweater right here, might be crackling a little bit. We're going to call that vector D. All right, so to go from the origin, add vector A, and then I should put a minus sign in front of this. It's the negative of vector B. We add that, it gives us a resultant vector of D if we were to go straight from the origin to the end of B right there. All right, so subtracting a vector is really like adding the vector, but in the opposite direction. A couple other math properties that they follow is that you can add them in any order. We call it the commutative property. So we can have vector B or minus vector B first, and then add to that vector A, which is in the positive direction, and it'll get us to exactly the same point right here. So in the same way that 2 plus 3 equals 3 plus 2, you can add vectors in pretty much any order that you want as well. What else happens with vectors? If you change the order of subtraction, it gives you the opposite of everything. All right, let's say we got vector A right here. Okay, so vector A, and we've got negative vector B like we did before, so I'm going to call that negative B right there. That creates for us, of course, I think I made that purple, right? Vector C. That's the resultant of A minus B. If you make everything opposite, it's still going to work out. So we can say that B is now the positive direction. Okay, we're going to call that vector B right there. If we add to that negative A, all right, negative A is plus negative A right there. So we're going to add the tail of negative A to the tip of B. Oops, that should be an A, right? A. That'll give us a vector, because remember we started at the beginning of B right there. So if we call this the beginning point or the origin, then that'll result in a vector of magnitude c, but it's going to be in the opposite direction. So that's negative c. I should have made that a negative a as well. All right. So a plus negative b equals c, in the same way that positive b plus negative a equals negative c. Gets you to the same point right there. And again, you can put them in pretty much any order. If you were to bring b over to this side, so we were actually to add vector b over to this side to get away from the left-hand side, that would be a plus vector b right here, which is what we have right there. So we can do the same thing with vectors as we can with any real values in algebra. All right. We can also multiply vectors. We're not going to be multiplying vectors by vectors, but we are going to be multiplying vectors by scalar quantities. Now, if you recall, a scalar is simply a measurement. It's a magnitude with no given direction. It's like somebody saying, like we did at the very beginning of the notes, if I walk into the town square and I say, where's the library? And somebody says, hey, no problem, it's a half a mile away. Well, you don't know what direction it is. They basically gave you a scalar quantity. So what we're going to do is take a directionless value and multiply it by a vector, and that'll give us a resultant vector. Here's what I mean. So say we'll say vector A, and I should have an arrow over that, is going to be 4 meters per second. Now here, this is a velocity vector, but it works exactly the same way. 4 meters per second at 30 degrees north of west. Okay, so let's say this is 4 meters per second, and that angle is 30 degrees north of west. Okay, we're taking that vector, I should probably write it next to the vector itself. Vector A equals 4 meters per second at 30 degrees north of west, and we're multiplying it times 2.0, which is really just a scalar. It has no direction. All right? So we're taking this vector and multiplying it by 2. What do we get? Well, we get a resultant vector, which we'll call b, right? But that means that since this scalar right here doesn't have any direction, all it does is multiplies the magnitude of this vector. So our resultant is going to be, if I have enough space over here, it's going to be twice as long. So it's going to be 8 meters per second. Does the direction change? No, because the scalar doesn't have any direction. That's still 30 degrees north of west. All that has happened is the magnitude has multiplied by that scalar quantity of 2. All right, so we have, it's kind of like saying, all right, well, this vector right here, if you take 2 of them, what do you get? Well, you just stack them tip to tail, and you would have that extra long vector that we would call vector b. Right there. Okay? How about this next one? All right, so we've got 18 meters, and again, that should have an arrow over it, at 50 degrees above the negative x-axis. All right, so let's say that's 50 degrees right there. There's a negative x-axis. That is 18 meters, we'll say. What happens if we multiply it by a scalar quantity of negative 0.5? Well, 2 things. First of all, the 0.5, or a half, makes it shorter, right? So that times negative 0.5 is going to produce what? Well, it's going to make it shorter. And what is the negative going to do? You can't have a negative magnitude, but you can have a negative direction. So it means that the resultant vector is going to be half the length of the original one. So that's 9 meters at, what is that angle right there? Well, if this angle is 50 degrees, then, well, it's really tiny in there. That angle in there should be 50 degrees as well. So this is, you might say, 50 degrees above the negative x-axis, right here, negative x and 50 degrees above. This is going to be 50 degrees below the positive x-axis. So that's at 50 degrees, not a very good 5, is it? 50 degrees below the positive x-axis. All right, so if you've got something that is made negative by a negative scalar, you can have a negative magnitude, but you can have a negative direction. So the absolute opposite of this 50 degrees above the negative x-axis is going to be 50 degrees below the positive x-axis. Complete 180-degree difference from the previous vector. Okay, it's going to be shorter, and it's going to be opposite. That's what negative 0.5 does. All right, lastly, We have vector A is 6 meters at due west. All right, well, that's pretty easy. 6.0 meters at, this is west right there. What happens if we multiply that by a scalar of -1? Okay, well, the fact that it's 1 is not going to change the magnitude. It's still going to be 6 meters, but the negative means that the resultant is going to be in the opposite direction. So the resultant, we'll call it vector, every time I take shortcuts here. Vector A is at vector B. The resultant is going to be B equals 6.0 meters at east. All right, complete 180-degree opposite from west. Similarly with north and south. Similarly with the previous one, this is 50 degrees above the negative x. This is 50 degrees below the positive x. So complete 180-degree difference right there. All right, that's a few examples of how we're adding vectors together. Excuse me. Multiplying vectors by scalars. That's going to be it for this segment right here. The next one is going to be on taking vectors and breaking them into components and then reassembling them. So for that, you'll need your graphing calculator, and you need it set to degree mode, not radian mode. And we're going to be doing some trig functions in that section. All right, but for the now, thanks for following along, and I'll see you on the next one.